Alrighty. Let me know when you guys can see the screen.
I can see it.
I can see it.
All right, so this is our final presentation for our tube laser and robotic arm, press brake arm implementation that we did with Action Fabricating. I'm Sean, worked with Dillon, Alex, and Jake. All right, so the agenda today is we're going to kind of go over their company background real quick, project summary, the timeline, the different kinds of quotes we received for the tube laser, and then go over the cost benefit analysis and return of investments on those. And then we'll go to the robotic arm quotes, and then the cost benefit analysis and return investment on those. And then we'll go through acknowledgements throughout the project. So just quickly, some background information on Action Fabrication. They're a sheet metal fabricating company based out of Detroit Lakes, Minnesota. They basically perform custom and general laser cutting, metal forming, robotic welding, and a lot more. They were first established in 1997 by Joe Gerdes in Detroit Lakes. And since then, Jordan Priam, Travis Stone, and Jed Sazama has taken over the business in 2008, and they all work together as partners. In 2007, they partnered with Minnesota Metalworks, making it their sister company, which allowed them to complete their parts from start to finish instead of having to outsource everything and bring them back in. They currently own and operate at four facilities nationwide with 77 total employees. These 4 facilities are located in Detroit Lakes, as we mentioned, Perham, Minnesota, Phoenix, Arizona, and Richmond, Virginia. So the project summary here, they were in need for 2 additions to their warehouse in Detroit Lakes, Minnesota. These 2 additions include the tube laser and robotic arm. The tube laser needed to outsource them and then figure out a project run rate for that. And then for the robotic arm, we wanted compatible with the current by Stronach press brake they have in their factory right now, as well as minimal programming, so less of a labor-intensive setup. So we initially got quotes from the vendors and then performed a CBA and ROI to provide feedback on the best options. This is just kind of our timeline right here. Obviously, at the beginning, it was more of, our statements of works, meeting with potential vendors, and then we began our research, and then we kind of got into constructing cost and savings with the cost benefit analysis and ROIs. And finally, we're here today presenting the final presentation.
So for the first part of our project, we're going to be looking at a tube laser, and this is just a video basically showing one of the tube lasers we actually looked at. So Sean, you can play that. And this is the Trump True Laser 7000. Basically, with a tube laser, it's mainly used for cutting metal piping, and depending on what level of tube laser you go for, it can cut all sorts of designs very, very quickly. And you'll notice with this head too, it also pivots to get different angles of cuts.
Can you advance your slides, please? I'm not seeing the video.
Oh, okay. Is it not sharing on your screen?
It's sharing. I just see the initial slide. I don't see any other slides but the first one.
Okay. I'm not sure why, but we can just move on from there.
Can you see the tube laser slide at all?
Nope, just the intro slide.
You're still in the intro?
Yeah.
Sean, can you unshare the screen and then reshare it?
Yeah.
There we go. Now it's advanced. Now you're on slide 8. Yep.
Okay, so upon meeting with Jed and Jordan, these are some of the desired specifications that they wanted for their two blazer. They're looking to cut up to about 24-foot long material. There's usually two options with the two blazer. There's a bundle loader and a magazine loader. They wanted to go for the bundle loader. And the three materials that they mainly cut are mild steel, stainless, and aluminum, and up to 8 inches in diameter. And then they wanted a pretty wide range for material thickness to cut from 0.04 inches all the way up to half an inch. And then they did ask about putting, or the potential to put the two blazer, kind of build it into an exterior wall. That way they can load the material that they keep outside just right into the bundle. That wasn't really possible that we found, other than if they wanted to cut out a hole in the exterior wall just to kind of feed it through there. But I don't think you really see that as necessary or quite worth it. And their ideal budget was from about $500,000 to $750,000. So
Dennis, wait, can Dennis see that we switch slides or no?
You're still on slide 8.
That's interesting. Is for everyone else, is it switching?
Yeah.
Okay.
Yeah.
Can you see the current operating conditions now?
Yep.
Okay. So currently they are, for their metal tubing, they're saw cutting and milling it. And so basically with this two blazer idea is we want to cut two operations into one. So they currently have one operator per each department, working about 168 hours a month. And with their current charge, what they charge to the customer, for saw cutting, they charge about $45 per hour, and then they charge an upfront 15% on top of that 45, which is that 1125. And then I talked to Jordan, and he said that they charge about 4 cents per part just for maintenance on the saw. And then for milling, it was $10 more for that hourly charge, which bumps up that setup cost as well to $13.75. And then the maintenance for the mill is about 3 cents per part. And so what their current costs are is it costs about $38 per hour to run each department. That's about all we know about the costs. So we're looking at $76 per hour for those costs. and about $153,000 a year. And then for their yearly revenue, they're looking at about $245,000, making their total yearly profits at $92,214.
Just quick, Dennis, I don't know if you saw it change, but I might just have to stop sharing and sharing again after each screen.
Well, now
slide is changed.
now I'm seeing it advance. So.
Oh.
Yeah, now I'm seeing it advance. I'm not sure what the initial issue was, but yeah, now I can see. When you had it in the full screen, I couldn't, but now I can see that.
Okay.
Do you want us to try just going
Yep,
small
you can leave it
screen?
right. Yeah, you can leave it right here on the small screen. I can still read that. It's not a problem.
Okay. So for the first quote that we had was from Bodor. Jake and I actually went and met up with a rep from them, and we went to a competitor that actually has two of these lasers, Broadway Welding, that's in Detroit Lakes. So they recommended the T230-9A, and originally this is a 2 kilowatt machine, but one of the add-ons is going to be that 3 kilowatt IPG laser upgrade for $70,000, and then that bundle loader as well. So the total quoted price after all of the smaller add-ons was roughly that $532,000. And then, so the projected return on investment with this particular two blazer. Now I added up, so I talked to a rep from Broadway Welding, the guy that's mostly running that machine, and he told me that it took him about 3 minutes to run 9-inch parts on a 20-foot stick. And so I kind of broke that down into cycle time per part or per so, and then I kind of broke that down into, okay, how much can that cut from a 24-foot stick, or how long will it take to cut a 24-foot stick? And if that's run all day, every day, what is their potential production? And it turned out to be like 15 times more than what they're currently producing. Obviously, that's not realistic. So we kind of decided to just up their production by 50% in the next year, just because it's a bigger, faster machine. They're going to get out a lot more parts and hopefully increase the production and keep that maintained. So working with that number, we're looking at about 225 jobs per month and about 6,750 parts per month. And the upfront cost of that machine, again, is just under 532 or 532,000. And then I didn't ever get a response from that rep from Broadway either. So I kind of assumed an rough estimate on hourly cost to run, just at $42 per hour. It could be more, it could be less. And then that brings their monthly cost to run at just over 7,000 and yearly just under 85. And then working with that 150% of production, we're looking at about 321 parts per day. And if they're going to stick with that current pricing, we're thinking charging about $75 per hour, and then increasing that setup cost because it is a more expensive machine. But we can keep that maintenance at about 3 cents per part. And then, so that'll bring that monthly Two Blazer revenue to just over 17,000. Moving on to the return on investment, the yearly revenue that we're looking at is just over 200,000. And then the yearly cost is just under 85,000. And we're looking at about 7 years for that lifespan, with an estimated profit of 837,000. So the yearly ROI is about 22.48%, making the payback period just under 5 years for that machine.
And so some of the other two Blazers that we looked at, our next two were both from the German manufacturer Trump. The first one that we looked at was the True Laser 5000 fiber. This one, the same as the Bodor, comes originally with a 2 kilowatt laser, so we'd be bumping that up to a 3 kilowatt laser, and including an automated bundle loader. The quoted price we're looking at for that is just over $1.5 million. We're assuming with the same laser power, we're going to probably run about the same production, so that same 225 jobs per month or 6,750 parts per month. We kept a lot of the assumptions here the same with our costs and what sort of pricing we're going to use for the customers. So we're looking at our first year cost to end up being just under $1.6 million. And however, we can bump, or we're going to keep the same yearly revenue at just about $204,000. And so even with an increased lifespan on this machine, we're going to end up taking quite a lot longer, just because we're not increasing our production that much more. So we're going to look at a yearly ROI of about 7.9%, or about 12.6 years to pay that off. The next option that we looked at was the True Laser 7000. This is just a step up from the last one. We're going to be stepping up to a 4 kilowatt laser. This machine can run up to an 8 meter in feed and out feed with up to a 10-inch diameter. on the tubing, and we're just going to be bumping the quoted price up to about $1.6 million. And with that increased power on the laser, we're assuming just a 10% increase in production. So that would bump our monthly jobs up to 240 or 7,200 parts per month. Our machine cost, as I previously stated, was just over $1.6 million. And with our increased production of 343 parts per day, our monthly tube laser revenue is going to be about just over $17,000 per month, or about $208,000 per year. Given that increase, we're still looking at about a 13-year payback period just due to the high cost of this machine, or about 7.7% yearly ROI. The next machine that we looked at is from Mazak, and this one is a little special because it uses some fairly new laser technology, the direct diode laser, which allows for more heat to be put into the cut and quicker cutting, especially with thicker material. The exact model that we were looking at is was quoted to us at about $1.62 million. And again, with that direct diode laser, we assumed another 5% increase in production, putting our monthly jobs up to 248 or 2,425 parts per month. That'll give us a monthly revenue of just under $17,500. And again, just with the high price of this machine, we're still looking at just under 13 years for a payback period, or 7.7% yearly ROI. The final machine that we looked at is from BLM, and they're kind of the go-to producer of these tube lasers. The exact model that we were recommended is the LT 8.2 fiber. This is capable of handling up to 8.5 meter in-feed and out-feed, up to, I believe, 8.5 inch diameter tubing. And our final quoted price was just about $1.5 million. And so this machine is also running on a 4 kilowatt laser, so we're sticking with that 160% production rate, or 240 jobs, keeping that's just over $17,000 a month. And for this machine, we're looking at a 12.3 year payback period, or 8.12% yearly ROI.
Okay, so for their current operating conditions with saw cutting and milling, I think we kind of went over this earlier. We're kind of looking to, so for current operating conditions, they're looking at about $92,000 for revenue per year, and about a yearly cost of $153, with revenue with yearly revenue at $245. You can go to the next slide. So it's just kind of recapping all of those. I think you go back a slide. So our recommendation for action is going to be to go with that Bodor tube laser, just because it's literally a third of the price and it has a third of the ROI and payback period. Plus, it's going to do just about the same as all of those other ones, other than that Trump Shoe Laser 7000 that's got the 4 kilowatt laser. and the direct diode laser from BLM. So we think this is a good option for them. It's a good start for them, and it's right in their price range. The other recommendation that I was talking about earlier was a new pricing recommendation for Action. The three of us, or the four of us, were kind of not fans of how they were pricing their revenue and their costs for their customers. We didn't really understand that hourly cost, and we kind of thought that maybe going with a price by linear foot would be a better option for them. And so what I did is I went to this website called metalsdepot.com and just kind of was looking to see what kind of prices they could be starting to look at. And they had some starting at like $5 per linear foot for steel, 6 for aluminum, and 15 for stainless. And I mean, we think this might be a good start for them. Obviously, if customers are ordering hundreds of linear feet of steel, you can kind of adjust that price in ranges. So if they order, 40 to 50 feet of linear, or 40 to 50 linear feet of steel, you can maybe bump that price down to $375 per linear foot. So that's just kind of a new pricing recommendation we want to introduce to them. Not only will this be a little simpler to track, but it'll also make them more money in the long run if they maintain this. And this is going to be the CVAs and ROIs with that new pricing system. So keeping that same production and same cost, with that new pricing, your daily revenue is going to be bumped up to just under $3,000 instead of $800. Now this is kind of where that disclaimer comes into, if they're ordering a certain amount of linear feet, you can probably try to knock that price down, just because you don't want to anger your customers with just huge inflation. But this will also help decrease that ROI to just under a year for payback. But I'd say if they were to introduce this new pricing system, they could for sure get their ROI for that boat or tube laser under 2 years. And then this is just kind of the some ROIs for the competing tube lasers with that BLM, Mazak, and that True Laser 7000. It's still pretty high. I mean, you're looking at 2.5 years for just about all of those. But just as in comparison with that Bodor, it was at 0.8 years.
Okay, so our next piece of machinery was the robotic press brake arm that they wanted to put in with their Stronach press brake. This will replace 2 operators in their working hours. We decided to still keep the setup times because you still have to set up the robotic arm. So this is kind of a video on how it operates and how it would work.
This video as well is using one of the robotic arms, or one of the 2 robotic arms that we actually got a quote and did some research on too as well. This is the Aceta robotic arm.
Okay, so for the research that we needed to do for the robotic arm, the specs that Jed gave us was it's got to operate in a 6x6 floor space, must be able to withstand a 30-pound load, which is a little bit odd range to find for robotic press brake arms. And then it must be compatible with existing Stronach press brake. And then the ideal budget was between $250,000 to $500,000. So this is kind of what we calculated for current operating conditions. For working hours per month, it was 168 per operator. So it was about 336 total hours. They run about 400 jobs a piece, and produce together 20,000 parts. And each one of those jobs is like it causes a 25% hourly rate setup charge. Well, that's included in there, and the estimated part cycle time was about 21.61 seconds. And later we'll find out what the robotic press brake arm was, or is. So the current cost, like Alex said, is $38 an hour per department. And so we did some research. They didn't give us really an hourly wage of an operator, but calculated it's about $24 per hour to run an experienced operator at one of those. So then the estimated cost per part was about 64 cents, running their yearly total cost to about 153,000. So now onto their current revenue. They do charge $55 an hour, and on top of that, it is also setup costs and maintenance. And that setup costs is again 25% of the hourly rate times the 400 jobs a piece. So it's like 800 jobs times the 25% of the hourly rate, which is about 11,000. And then the maintenance came out to about 1,400. So overall monthly revenue, you're looking at $30,000, and that translates into a current yearly profit of about $218,000. So the first robotic arm that I researched was the Aceta robotic arm that we saw in the video. It's called Ribs 1. The base price was about $277,000. There's an installation estimate of $26,000. Then they do offer the operator training program, which is about 40 hours and about five and a half grand. So the total ends up being about $309,000. And I'll talk a little bit later about installation and how it could possibly delay their production for a whole month. So the new assumptions in project return on investment, new hours, we're going to keep the setup hours because you still have to program the machine for different parts, but we're eliminating all the operator hours since it will be automatic. And some of the new specs, it's a little bit faster than a human operator. It's at about 15 to 20 seconds per part, depending on the part. So even then, you're still producing 21,000 to 28,000 parts, which is about 2,000 to 9,000 more parts than it already is, and that lowers the cost to 23 cents per part, or to 23 to 31 cents per part. And there's a lot of benefits with using press brake arm instead of operators. There's reduced human error, which is huge, increased productivity, high versatility, and increased operator safety. So the initial cost, like I said, the machine is $309,000. Installation, this is where we run into if they can install it. I don't know if they can use both sides of the press brake. If they can install it on the one side and still use the press brake for that month, and still not lose as much money, but they're looking at a potential loss of not using that press brake for a whole month, which runs to about 18 grand. So that'll cost them. Training is included in that machine cost, like I said. Then the operation costs. So we use that operator setup per month. We use that $24 an hour times the 200 hours it keeps or takes to set up the machine. And then hourly upkeep, we did research online. It's about $4 an hour. So now you're looking at for the first year cost, it's like $401,000. So, but after that, the projected revenue, parts per month, 25,000 parts per day, parts per day, 1,190, and then jobs per month. We're gonna keep it at 800, keep it the same because, like Alex said, the hourly charge is kind of different. So if you keep the jobs the same, we're just gonna speed up the process, and if you charge hourly, it's kind of gonna mess around with that. Is you're actually going to kind of lose profits because you're going to be producing parts faster and losing money actually. So now the press brake hourly charge is still going to be 55. The setup costs will be $13.75 an hour. Maintenance will be about 184. And then the press break revenue per month will end up being 30,954. So you're coming out at 297,000 a head. Yeah, that's so then the return on the investment the yearly machine revenue is 371,000. Yearly machine costs is about 73,000. And the estimated lifespan, we said 10 years. Estimated lifetime profit is about 3 million. So the yearly ROI will be about 90%, and the payback period will be about 1 year.
Okay, the other robotic arm that we researched was by Stronach. It's called the Expert 40. It actually ties perfectly into the press brake right now, so everything with the installation would be pretty easy, a lot quicker than the Aceta robotic arm. Basically, we're looking at a total price of about $204,000. The cool thing about this is all their training is actually done in one of their facilities out in Chicago. So they offer basically an all-inclusive trip to Chicago where you can learn training and stuff like that. So that's an option for Action. So kind of looking at the ROI for this machine, kept everything the same or similar, keeping setup hours per month about 300. With that being said, it would eliminate about 136 operator hours per month. We're looking at a similar cost per part. So the machine costs about 204,000, like I mentioned. The installation's a little less. Money-wise as well as time-wise, it takes about a week, a lot quicker. So they'd have a lot less downtime if they needed to shut down the press brake. And then coming out for a total cost of about 290,000 for their first year. Parts per month for their projected revenue is about 25,000. Similar parts per day at about 1,200, and then jobs per month at 800. Using all the hourly charges and setup cost, as you see there, the estimated yearly profit is near 300,000. So using yearly machine revenue about 371,000, and the yearly machine cost is 74,000. You get an estimated lifespan of about 27 years with that estimated lifetime profit of almost being 3 million. This causes our ROI to be 137%. Numbers could be a little off, which is why that is so high, but it is definitely a lot greater than the Aceta robotic arm, and then with a lot shorter payback period of about 0.6869% or payback period. So our final recommendations we kind of used for Action Fabricating is to invest in that Bodar tube laser, with the payback period being about 4.5 years versus that 12 to 13 years in their current pricing model, and then increased yearly profit of around 27,000. For the robotic arm, we recommend investing in their by Stronach Expert 40 robotic arm. The initial cost is a little greater than 30% or less than 30% with the same anticipated yearly income. The payback period is almost about half of what it is for the Aceta, and then the yearly ROI is about 47% higher. And then, like Alex mentioned before, incorporating that new pricing system for the tube laser to drive up their profits. So kind of a project recap. Kind of just went over the background, kind of what Action Fabricating is all about. Looked over our tube laser research and quotes, as well as the robotic arms and quotes, and then did a CBI and ROI on both of those, and then provided you with recommendations. Some acknowledgements we want to throw out there. Definitely for Jordan, Priam, and Jed Sazama, who are co-owners at the plant in Detroit Lakes, and for their whole company as a whole. They allowed us to work with them hand in hand, allowed us to come in their factory and see what they're all about, and we're very responsive on their email for all the data that we used. Obviously, you can see there's a lot of data. Without them, all that would not be possible. Obviously, we want to thank you, Dennis, for all your hard work, providing all the tools we needed to complete this project. It's been obviously tough with the whole coronavirus going around, but you made it possible, and we're very grateful for that. Obviously, Dr. Grewell for all his help. I know he's kind of more behind the scenes for this class, but definitely someone that we're grateful for. And then obviously the rest of the IME capstone class. We've grown together for the last 4 years, and coming out and being able to put projects on the line and help out in the real world is pretty cool to see. And then the entire engineering department for making this all possible. Do you have any questions?
Yeah, can you back up to the slide that lays out the requirements for the tube laser, Sean?
Yep. You're looking at this one?
Yeah, the requirements that they laid out in there. So, and there was a big disparity between the $500,000 tube laser and the $1.6 million tube laser. So I guess the question would be were the ones that were 3 times more expensive really in your minds 3 times as more productive or useful? Or could they expand those to other applications that maybe they didn't define as their spec?
The way that we kind of saw it to be was that they had about the same capability. We really didn't get a chance to see what was, 3 times more, or what you're getting for 3 times more money. Except, other than that pivoting head with the True Laser 7000 and the direct diode laser, they're all going to basically do the same thing. And with Action being not a huge fabricating company, we really didn't see the need to go for and spend that kind of money for a slight increase in their production. The Bodor tube laser is going to do just fine with 150% of their current production, and for a third of the cost.
Was there anything in those other 3 that when you showed them to Jordan that he liked, that the one that you did suggest have capabilities to do? Anything he liked about those other ones? Probably nothing he liked enough to pay an extra $1 million for.
Yeah, there were some things that he commented and said that, oh, that's nice, that would be cool, but he kind of, the reaction to the tripling of the price was kind of drawn back and kind of like, oof, I don't know about that.
Yeah. So the other question I have, I don't know if you did any research or you got any input from Jordan, but did they feel that they're going to have any issues or concerns keeping these tube laser and this robotic arm busy enough to get the ROI that you guys pushed out there?
Yeah, obviously that's a big thing, because when we calculate our ROIs, it's basically using max production on both of these machines, which in the real world probably isn't accurate, to say the least. But with their current production right now, they're running these machines on a high level. Parts are usually flowing. I know when we visited a couple of times, both the tube laser that they have currently is running at a high level and a high pace, as well as that press brake, which is also a reason why they wanted to add these additional machines just to keep up with the production. So we believe that full ROI might not be exact, but it will be relatively close in the long run.
I'm just going to make a little small correction to what Sean said. They don't currently have a tube laser, but their saw cutting and milling departments were running at full operation.
So you don't see any problem with them keeping these things rather busy if they do purchase them, correct?
Right.
Okay. Yeah, that's something else you can always look at, is if they can keep these busy, if there's a backlog of a product that they're looking to make, or if these are the pinch points in a production line, that just makes the validation of these types of ROIs and benefit analysis that much easier. So something you could take a look at. And in your observation, it sounds like they do have a pretty good backlog, and they probably could keep these rather busy, as busy as they want to anyway. So, okay.
And Jordan had sent me, or I think Jed had sent me about 10 part drawings that they run. And I mean, they run from 7 inches long in length to 68 inches in length. So, and there's time that goes into, you know, programming which part they're running. And so that setup time. So with that added in, I really don't see them not being busy.
Okay. So your recommendations were good. I think that you had good follow through. Were they pretty? Was Jordan and Jed pretty receptive to the recommendations you guys put out there?
We actually haven't currently finally met with them with their
Okay.
busy schedule right now. We're waiting to hear back from them, but we're probably going to provide these recommendations to them either later this week or early next week. But
Okay.
obviously, we worked hand in hand with them, so they obviously know the machines that we're working with, and seem pretty happy about which ones are showing the most accurate results and stuff they could build off of.
Okay. Yeah, if you can schedule a time to do the presentation to them, just like you did to me, that would be great. If not, we could probably, well, they'll get a copy of the recording because I'll be sending the recordings to all 10 projects out to all the 10 sponsors. So they see that, but it'd be nice if you could just do a presentation, have a little Q&A so they could ask some questions at the end if they had anything. So schedule that, see if you can put that in place. Go ahead and send me the recording of this, send me the PowerPoint presentation, and then the final project report is actually due end of day next Friday, the 1st of May. Yep. So
Okay.
that's all I got.
Okay.
All right.
Thanks,
sounds
Dennis.
good.
Thanks, everybody. Well, that actually,